What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're looking at lesson 10.2, finding arc measures. So we'll be able to find arc measures, identify congruent arcs, and then be able to prove circles are similar. The first thing we need to know are a few details about types of circles. We have a central angle, which is an angle whose vertex is the center of the circle. That's easier to understand, but we also want to add a few things here. Okay. A minor arc is an arc that is less than 180 degrees, and typically you write this with a 2-letter name. A major arc is an arc more than 180 degrees, and you're going to use 3 letters to name this one. Okay. And then a semicircle, we'll see that a little bit too, an arc with endpoints on a diameter. This one would also be a 3-letter name. So we can pretend that we have this circle here, okay, and we have C is in the middle, we'll have A here, and then B here, okay, and maybe we can have like point D on the outside, okay. The minor arc we would write as A, B with little curve on the top, and then to write the major arc we can say major arc is ADB with a little curve on the top, okay? So with majors, that's why we have to have our 3 letters, because we're extending more than 180 degrees, okay? Measuring arcs. The measure of a minor arc is the measure of its central angle. So for instance, if we were looking at the measure of arc AB is just the degree measurements of AB. Or ACB, that angle here. But if you want a major arc, then you would take the difference of your minor arc and subtract whatever that was left over. So in this case, my major arc's measurement of ADB will be 360 minus 50, which is 310 degrees. All semicircles are going to measure 180 degrees. Okay, so that's pretty simple information here. We're going to try some examples. Find the measure of each arc of point of circle P where RT is the diameter. Since I know RT is the diameter, that's making my 180 degree angle, and I already can see that if you want to call it arc ST is a part of that. So something we maybe can consider is that's making 180 degrees, so that could be 70 degrees there. Let's go ahead and start where we're looking. RS is already given to us, that's 110 degrees, okay? But RTS, that's your major arc, so we would find that by taking 360 and subtracting 110, okay? That'll give us 250 degrees. The last one we want to look for is RST, and if you notice, RST is going halfway around the circle, and since it's already given to us that RT was the diameter, that one is automatically 180 degrees, okay? Next up, we're going to add a postulate in here. This is on your theorem sheets. You can draw this picture if you'd like to. The measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So for example, the measure of the arc ABC can be found by taking the measurement of AB plus the measurement of arc BC. So that's pretty simple. I would recommend drawing this picture here just because it gives you a visual. If you even want to color code AB and BC's arc, you can do that as well. All right, next up, we're going to look at finding some measurements, okay? So let's start with GE. So G to E is just adding your 40 plus 80, and that's going to give you 120, okay? Next up, GEF will be adding all of these, so 40 and 80 and 110. So here I'm going to G, then to E, then to F, okay? That will give me, where are we at? 230, okay? And then GF, which is this way, would be just taking this difference of 360 minus that 230 we just found, and that'll give us 130. Okay, so these on the next slide, I'm going to have you pause this and try these. Okay, a recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph shows the result. Find the indicated arc measures. Go ahead and pause the video now. Try these on your own, and when you're done with A, B, C, and D, go ahead and click play. So the arc AC can be found by adding 29 degrees plus 108, and we're going to get 137. Okay. The measurement of ACD, so going from A all the way around to D, we would still take that 137 we got, but then adding on that 83, and we're going to get 220 degrees. Then we've got ADC, so going the opposite way. I'm going to erase this guy right here. So ADC, we've got actor, other, and athlete, so that would be 79 plus 61 plus 83, and we're getting 223. And then the measurement of EBD, so E, then to B, then to D, is essentially everything minus 61 degrees, so we can take 360 and just subtract 61 and get 299. Okay? Next up, we're going to talk about identifying major, minor, or semicircle. I feel like you can try these on your own as well. So let's go ahead and pause here, try 1 through 6 on your own, and when you're ready to check, go ahead and click play. Once we find that, we're also going to find the indicated measure. So TQ is a minor arc, and it is 120 degrees. QRT. QRT looks like it's going to be a major arc already. And one thing we might want to do is find QRT's missing piece, or just take this leftover 120 minus 360. So 360 minus 120 is going to give us 240. Okay. Sorry. Then we've got TQR. TQR is a semicircle. So semi, and that's 180 degrees. We have Q to S. This one is going to be a minor arc. And Q to S is going to be 160 degrees. Okay. TS, we've got minor arc as well. And that's 80 degrees. And then RST. RST is a semicircle. So that one is also 180 degrees. Okay. A little bit more than we're finishing up. So we've got 2 theorems. And what we're going to look at are, just make sure we're recording these in our notes. So 2 circles, first off, are congruent circles if and only if they have the same radius. Okay, so it might be beneficial to draw these pictures right here. A and B, A circle A and circle B are congruent if and only if AC is congruent to BD. And then the congruent central angles theorem just states in the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding angles are also congruent. So arc BC is congruent to arc DE if and only if BAC's angle is congruent to DAE's angle. So again, drawing this little picture here, maybe that description below. If needed, go ahead and pause the video here. When you are done writing those down in your notes, click play to see what happens next. All right, we're going to tell if the red arcs are congruent and then try to describe why or why not. So we're going to start with letter A. So we have arc CD and we have arc EF. Those are going to be congruent due to that central angles theorem. Okay, looking at letter B, we have arc RS and we have arc TU. Okay, these are not congruent because they have the same central angle but not congruent circles. So therefore they won't have the same arcs. And then for letter C, we have arc UV highlighted in red, and it looks like it is congruent to arc YZ because you have your same central angle and you have your congruent radius, or we can say congruent radii for multiples there. All right, if you haven't tried these on your own yet, let's do so. Let's take a pause here, try these on your own, and when you're ready to check them, click play. All right, tell whether the red arcs are congruent, explain why or why not. Arc AB is congruent to arc CD because of that central angles theorem, and they are also congruent circles. Okay, and then over here for arc MN, it is not congruent to PQ arc because the circles don't match with radius. Okay, we got one more theorem to look at, and this one is just stating all circles are similar. That's really all you need to know. There's no picture to describe that one. And that'll actually conclude our video for 10.2, finding arc measures. Hopefully you found this video to be helpful, and we will catch you next time when we learn a little bit more about circles. Have a great day.